I'd like to introduce you to the Pythagorean theorem. Okay, so the Pythagorean theorem states that for any right triangle that I have, okay, so this is a right triangle and it only works for right triangles, that the area of these two smaller squares here, the green and the yellow square, if I add those two areas up, it'll equal the area of this larger square. So let's give these some names here. I'll label this side C. So that means that the area of the square will be C times C, or C squared. I'll call this side B. So B times B, the area of this square is B squared. And then this square here is A. So that side is A. So the area of this square is A squared. Okay. Now A and B we usually refer to as legs. Okay. And C, that longest side, the longest side in a right triangle, which is also opposite the right triangle, we call the hypotenuse. Okay. So when we're stating the Pythagorean theorem, we usually state it in a couple of different ways. We'll say that a squared plus b squared equals c squared. And if you want to rearrange that to say c squared equals a squared plus b squared, that works equally as well. The other thing that we sometimes say is that we say the leg squared. So I'll just say L, leg squared plus leg squared equals the hypotenuse squared. Okay, so a couple of different ways of representing the Pythagorean theorem. What I'd like to do quickly here is just show you why that works the way it does. And we have a really neat sort of graphical proof here that I can show you just in a minute or so why the Pythagorean theorem works the way it does. So you can see on this page here, what I did is I took a triangle. Now this is a right triangle, and it has to be a right triangle. Remember, the theorem only works for right triangles. So I just drew a random one, and then I repeated it 3 more times. And I rearranged the triangles to make this shape. Okay, and this shape here, I have a large square here. Okay, but inside I also have a square, and you can see here that this side here is C, that side here is C, and all these angles are also right angles. Okay, you could show that pretty easily. So the area inside here is C squared. So what I want to be able to do is say move around these 4 triangles here and preserve the larger area here and show that C squared can be rearranged to be A squared and B squared added together. And I'll show you how that's done. So here, just for your benefit here, I traced out the larger square here. And what I'm going to do here now is just take these triangles that are here and just move them around. Okay, so I'll move that one down here. I'll shift this one over here. And I'll shift this one up here. And what we see here is that I have 2 new squares. Okay, I can see here I have the 2 smaller sides here, so I can say that that would be A squared, and I have the 2, say, longer legs here, and I can call that B squared. So I still have the 4 triangles and this white space here. And you could see pretty easily that the white space on both of my diagrams will be the same. So I think you should be able to see there that that shows that A squared plus B squared equals C squared. You might want to try it for a different size right triangle, but it doesn't matter. Whatever size right triangle you do this for, it will come out to be the same. So that's why the Pythagorean theorem works the way it does. Thanks for listening, and we'll work more with the Pythagorean theorem in our next videos.